Welcome and hello. This is a video tutorial on HEC HMS, and in this lesson, I'm going to be talking about the gridded hybrid snowmelt method. So within a subbasin, you can have a snowmelt method assigned, and one of those methods is the gridded hybrid type. That's what we're talking about in today's lesson. All right, what I have on the screen here is my watershed. It has already been delineated, and you're seeing a number of subbasins here. I'm going to zoom in here on the downstream-most subbasin, number 45, and then we're going to use this one for the lesson. If I click on the subbasin 45, and then it pops up as selected in my Watershed Explorer, and then down in the Components Editor, we now have a snow method. Now our options here for the snowmelt method is none, energy balance, gridded energy balance, temperature index, gridded temperature index, and then this last one is gridded hybrid. And gridded hybrid is the method that we're going to be talking about here in this lesson. The gridded hybrid method of determining snowmelt uses a radiation balance rather than a temperature method as a proxy for available energy in the snowpack. This method includes spatial variability in shortwave and longwave radiation and is therefore well suited for watersheds with forests and steep terrain. All right, so again, I have the watershed selected. I went ahead and selected gridded hybrid. Now, when I did that, I now have a snow tab. Let me go ahead and make this a little wider. Yeah. So the first sub tab here is for subbasin, and then the next one over is snow. So this is for the snow melt. Now I have a bunch of parameter data that I'm going to fill out for this gridded hybrid snowmelt method. The first one is initial values, and our two options in this drop down is default and parameter grids. So if I select default, that's what it is by default. HMS has some default values, which I'll discuss at the same time as the parameter grids. So if I select parameter grids, that means when there's a grid on this particular subbasin, each cell in the grid will have a different or potentially different initial value for the snow water equivalent, the initial liquid, the initial albedo, and so on. They may have the same values, but they would probably have some variability in the values as well. If we select the default values, then one single value would be used for the entire subbasin for these 5 parameters. The first grid that we need to define is the initial snow water equivalent. This is the depth of water that would result from all the snow melting. So if the snow happens to be 5 feet deep, you may only have like 1 or 2 feet of actual runoff. So the snow water equivalent would be 1 or 2 feet in that situation. Right now, it just says none. What it's looking for is a gridded data set. And we can add that gridded data set to our model by going up to the components menu here and then grid data manager. Then for data type, we want to select snow water equivalent grids. So let me just find that. Snow water equivalent grids is right here. Next, let's click the new button and then we can type in or paste in a name and a description if we want, and then click create. So I'm going to go ahead and close that grid data manager and then navigate to the top, collapse the basin. And now we have this directory for grid data. So if I expand that, I've got a directory for snow water equivalent grids. And then if I expand that, we see our snow water equivalent. SWE45 is what I'm calling it. Down in the components editor, I have some data I need to fill out, specifically the data source. It could either be a DSS file, multiple DSS files, an ASCII file, or a GeoTIFF. Based on this data source selection, I would have to fill out a few other fields down below. So in the case of a single DSS record, I need to specify that DSS file name and the DSS path name. Once all that is input and saved, we can go back to the subbasin and then click on the snow tab again. And now for this initial snow water equivalent grid, we should have our option here, SWE45. So that's how that works. Okay, the next one down is initial liquid grid. This is the percentage of snow that is in liquid state, and this would only occur if the snowpack is melting. So if there's no snow or it's been very cold for a long time, then this value would be 0. In fact, that is the default value if you select default here. But if there is a value, then we would go ahead and select the gridded data set for that initial liquid grid. I'm going to go ahead and do this one as well, and then we won't do all 5, but just 2 I think would be a good starting point to show everyone how it's done. So we're going to go back up to our components menu and then grid data manager. Go ahead and click new. Sorry. Actually, I need to select the data type. The data type is going to be liquid water content grids. So here it is. And then I'll click new. Again, you can go ahead and type in a name or paste in a name, add a description, and click create. All right, let's double check that grid file was created. And sure, under grid data, we have our liquid water content grids, and then LWC 45 is right there and ready to go. As before, down in the component editor, we need to uh, provide some data. And then let's go ahead and just double check that that is selectable. And there it is for a liquid grid. The initial albedo grid is set to zero point 0.4 as a default value. It ranges from 0 to 1.0, and it refers to the fraction of incoming solar radiation that is reflected by the snow surface. It is a dimensionless quantity, again, ranging from 0 to 1. If we were to input a grid for this, we would go up to the components menu again, grid data manager, and then the type we would use is albedo grids. The next is the initial ATI grid. This is the initial antecedent temperature index. Default value, again, if I selected just default here, would be 0 degrees Celsius or 32 Fahrenheit. This is a measure of the accumulated thermal energy in a snowpack, reflecting the influence of past warm temperatures. So if there's no snow, then the value is 0. But if there is, then the grid that we would select here for initial ATI is going to be of type temperature grid sets. And then the last grid we need to input is our heat deficit grid. The initial heat deficit describes the net heat loss from the snowpack since the start of the simulation. So for this grid, we would go again, grid data manager, and then the data type would be called cold content grids. So go ahead and check out the user's manual if you need more information on how these grids are added. All right, so those are the initial grid data. We still have other parameter data to provide for this gridded hybrid snowmelt method, such as the rain threshold air temperature and the snow threshold air temperature. Now you notice that there's already values provided here, and I did not put those values in. They were here as soon as I clicked the snow tab for the first time, but clearly they are editable and wouldn't always be these numbers for every situation. If the air temperature is greater than the rain threshold air temperature, then the precipitation that falls will be rain. And if the air temperature is less than the snow threshold air temperature, then the precipitation that falls will be snow. If the air temperature is somewhere between the rain threshold and snow threshold air temperatures, then that precipitation would be partially rain and partially snow, depending on the air temperature and, of course, these threshold air temperatures. The base temperature is the temperature above which snow begins to melt, typically around freezing temperature, but it could also be a few degrees one way or the other. The melt factor is a parameter used to estimate the rate of snow melt based on the air temperature in relationship to that base temperature. Next up is the max negative melt factor. And what that is a value used to calculate the heat deficit within the snowpack. Melting occurs when the energy input into the snowpack overcomes that heat deficit. The ATI coefficient is next, and its value here is 0.8. The ATI coefficient modifies the impact of the antecedent temperature index on the snow melt rate. It essentially scales the influence of the accumulated warmth on the rate at which the snow melts. And I know I'm just reading the descriptions here, and you really learn more when we actually run some models and tweak these numbers. But we got to start with the definitions. We got two more. The wind function is this penultimate parameter here, and that is used to calculate the impediment of flow of vapor by the temperature gradient. And the last one here is water content. This is the content of water within the snowpack that is required before the liquid would actually seep out and be part of the runoff or infiltration. Okay, so that is it for our parameters associated with the gridded hybrid snowmelt method. There are a few other things that we need to do for our watershed using the gridded hybrid snowmelt method. And the first is we need to add a meteorological model and provide some initial conditions. So to do that, we'll go up to components, Meteorologic Model Manager. Next, we need to add a model. So we'll go ahead and click the New button. Then we can type in or paste in a name for that model and then click Create. Our Watershed Explorer now has a meteorologic models directory, and here is the model that we just created. Down below in the components editor, this gridded hybrid snowmelt method requires that we input the incoming shortwave radiation, that's shortwave, and then the incoming longwave radiation, longwave, the precipitation, air temperature, atmospheric pressure, and relative humidity. This is all required before we run a simulation. Something else that's required before running a simulation is the terrain data and pre-processing. So right here we have our terrain data that's associated with the basin. If you right click, pre-process slope and aspect, and then also pre-process the solar shading. So these are two more steps that need to happen. I'm not going to do them here in the lesson, but they need to happen before the simulation can run using this gridded hybrid method. The last thing I want to mention though is if you go up to parameters and then Snowmelt and then gridded hybrid, this is the global editor. So you can see all the subbasins in the watershed that have been assigned this gridded hybrid Snowmelt method. Right now it's only subbasin 45, but you can imagine that if there's lots of data here, it would be nice to be able to sometimes see how the different subbasins compare and their values. All right, well, I'm going to go ahead and close that. This is the end of the lesson for gridded hybrid snowmelt method. We selected the subbasin, we clicked on a snow tab right here, and then we added the parameter data. After that, we went up and assigned a meteorological model, and then we pre-processed the slope, aspect, and solar shading in the terrain data.